Hello, welcome back to our next lesson in biology. We're beginning Unit 3 now, which is on biochemistry, and we'll be talking about organic versus inorganic molecules first. So the learning target for today is that I can distinguish between organic and inorganic molecules and identify the 6 most common elements in organic molecules. So, what does this mean? Let's start with organic versus inorganic. We actually covered this in Unit 1, but let's go back and review this. So, molecules with carbon in them are called organic. So they must contain carbon. That's pretty much it. You should also know that pretty much everything that's alive or any living organism is going to be organic. It's going to contain carbon. You could not have life, on Earth at least, without carbon. Molecules without carbon in them are called inorganic. So if they don't have carbon, you can bet that they're inorganic. It's as simple as that, really. So let's talk about why, though. Why is carbon so unique, and why is it so good for building life? Why is it so important for life? So it's unique because it has these 4 valence electrons around the outside of it. And when you have these 4 valence electrons, it allows it to create these long chemical chains. So chemistry students or students that have already taken chemistry will remember this. The valence electrons, the outside electrons, are the ones that are going to react in chemical reactions. And because carbon has 4, it gives it a lot of possibilities. So let's look at that. All right, so bonds are based on electrons. Chemical chains are caused by atoms bonding by their valence electrons. All right, what I just said. You can't form a bond with another atom without sharing or exchanging electrons. So because of the shape of carbon and because of the number of valence electrons, it allows it to make really long chains, really long carbon chains. And we make all different types of molecules from that. So let's look at what a molecule is very quickly. So chains of atoms are called molecules. Atoms bond or connect with other atoms to make these molecules. So in chemistry we learned that more than one atom combined makes a molecule. One of the most common ones we know of is water. We have an oxygen combined with 2 hydrogens. We have carbon dioxide with carbon on the inside and oxygen on the outside. So CO2, H2O, those are small examples of molecules. Alright, so to make a stable molecule, you need to have a full valence shell of electrons. What that means for most atoms is that they would like to have 8 electrons in their outside shell. 8 electrons is a happy atom. So you can see here these 2 fluorine atoms coming together. They both had 7, but when they can come together, they get to share their electrons, and then they add up to 8. So we look at this fluorine atom 1, 2, 3, 4, 5, 6, 7, but when he shares it with his partner over here, he gets an 8th one, and it's true for the other fluorine atom. Alright, so here's another graphic representation of that. Alright, so having 8 electrons makes molecules happy. Alright, so because carbon is the way it is, it has 4 openings or 4 electrons that it can share with other atoms. That means that it can combine with many different possibilities, and the most common organic molecules are below. So in addition to carbon, you also have hydrogen, which can give carbon 1 electron at a time. You have oxygen, which needs 2 electrons. You have nitrogen, which needs 3 electrons. Sulfur needs 2 electrons, and phosphorus needs 3 electrons. So all of these different combinations allow carbon to be very flexible, and it can make many different types of molecules. Alright, so why these elements? These elements have enough valence electrons to bond with carbon easily. Alright, look at this picture here. We have 2 oxygen atoms. Look how they need 2 electrons here to fill their need. Well, it just so happens that carbon has at least 2 to give. So if we put together 2 oxygen atoms and a carbon atom, you can see how now carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, so carbon's happy. Looking at oxygen, 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen over here also has 8 electrons. So with 8 electrons, that makes carbon, makes oxygen happy, and you make the familiar molecule called CO2. Alright, and that's it. I mean, that's a lot, but that's it. So carbon is very flexible, and because of that, it's very important to life. So to review, organic molecules contain carbon. Atoms combine to form molecules. Carbon often combines to make organic molecules with hydrogen, oxygen, nitrogen, sulfur, and phosphorus. You should be able to understand why carbon is so important, but at the least you need to know these 3 things to do well on your exit ticket. Thanks. Bye.